All right, so in this video, we're going to take a look at, while at first glance, the limits may not seem to be the indeterminate form as discussed earlier, but with some algebraic manipulation, we can put them in the form of 0 over 0 or infinity over infinity. Right? The first of these being, so first of all, what am I talking about here? So I'm going to be looking at products of the form 0 times infinity, right? Or infinity times 0, right? Whatever, vice versa, right? Either one without loss of a generality, I can refer to either one of these products. So if I do have a product of functions, f times g, right? Let's say f is going to 0 and then g is going to infinity. By using just the property of reciprocals, right? These are two equivalent statements, right? And now in doing that, right, f is going to 0 and g is going to 1 over infinity, but 1 over a large number is 0. So now what this is of the 0 over 0 form or the indeterminate form, right? And vice versa here, if let's say, still f going to 0, g going to infinity, if I had this. All right, well, g is going to infinity, and then 1 over small values, right, approaching 0. This whole quantity goes to infinity. So we have infinity over infinity, our other indeterminate form. Okay, so now that means that we can take a look at evaluating something like this, right? The limit as x goes to negative infinity of x e to the x. All right, and again, don't focus too much on what the sign value of the function is, right? Whether it's negative infinity or positive infinity. The fact that it goes to infinity will allow me to write it in this indeterminate form, right? So as x goes to negative infinity, right, x is going to negative infinity, but this, recall this is going to 0, right? 1 over e to the infinity. So that's a very large number, right? 1 over a very large number. That is going to be 0. So I do have this product form, right? 0 times infinity. Right? So what I can do is I can use this form here and rewrite it like this. All right? So as x goes to infinity, all right, again, now I have here 0 over 0 as x goes to negative infinity. So I could take the derivative of the numerator and the denominator, and let's see what we get here. And actually here, you know what, I think here I'm hesitating here. So the reason I'm hesitating is if I do L'Hopital's rule, right, it's not going to get me anywhere, right? Limit as x goes to negative infinity, I get e to the x over negative 1 over x squared, right? So here in both cases, we still get infinity over infinity. So actually, I think the approach I'm going to take is, so I'm going to discard this, right? And I'm going to take the same approach of the reciprocal, but I'm actually going to switch up which one I take the reciprocal of. All right, e to the negative x. Remember, 1 over e to the x, but that's just a negative exponent. So I'm going to do this one here. Okay. All right. And then plugging it in here, so I'll take the derivative here. All right, so taking the derivative, applying L'Hopital's rule, we get the limit as x goes to negative infinity of 1 over negative e to the negative x. Okay, and then applying the reciprocal rule for exponents, the limit as x goes to negative infinity of negative e to the x. So as x is going to negative infinity, this overall value is getting really, really small, right? In fact, it is approaching 0. Okay. All right, and again, notice that was something that I could not get from my first attempt here, right? So again, always important to realize that just because you try, you're like, I'm gonna try this way, all right, and it doesn't go the way that you planned, doesn't mean that you did it incorrectly or that that it's wrong or that I can't use it, right? It just required some refinement on my end. Right, so let's try another example here. How about something like this? So I want to go the limit as x goes to infinity of x sine of 1 over x. Right, so again, notice as x goes to infinity, x is getting really large, right? X is becoming infinity. 1 over x is going to 0, right? And then sine of 0 is going to 0, so we get this product form, infinity times 0. So I'm going to take the same approach here, the limit as x goes to infinity of sine of 1 over x over 1 over x. Okay, and then I'll apply L'Hopital's rule, right? Here I have, as x goes to infinity, I get 0 over 0 times. So what is indeterminate? So we take the limit as x goes to infinity, cosine of 1 over x, don't forget the chain rule. So we get negative 1 over x squared, and then derivative of 1 over x is negative 1 over x squared. All right, and then here we notice that this reduces, so we get the limit as x goes to infinity of cosine of 1 over x, right? So no longer, L'Hopital's rule no longer applies, but again, I don't need it. As x goes to infinity, right, that value is going to 0. All right, but cosine of 0 is indeed just 1. Okay, and that's how we use the L'Hopital's rule for products that are of the type infinity times 0.